Hi, in this video we're going to be creating a simple CRUD API using AWS services. Just as a heads up, I will not be signing up and setting up an AWS account from scratch. However, I've put a link in the description to a blog article that shows you how to set up an AWS account in case you haven't done that yet. Now, what is AWS? AWS is a platform as a service that offers you a whole suite of cloud services that you can use in combination to create, build, deploy, and maintain any type of computing application. From machine learning to mobile apps to databases to hosting to storage, etc., etc. You can essentially do anything you want on AWS. And it's got a great free tier plan, which we will get into later. Now, what is Lambda? Lambda is a service that leverages the serverless architecture and allows you to split your code into multiple functions, hand it to the cloud, and let it do the rest. You don't have to manage a server, hence the serverless keyword. This is key because this frees you from having to configure, run, maintain, and even scale your servers, because this is all done automatically by Lambda. Now, Lambda supports multiple languages, including Java, Python, JavaScript as Node.js, and a couple of other server-side languages. For this tutorial, we're going to be using Node.js. Now, this is the typical flow of deploying Lambda functions. First, we configure our project by outlining what functions you're going to use, or what function, it could be just one function, and what other services that relate to this function that you need that you're going to use. In our case, it's going to be DynamoDB as a database, and what permissions that you want to give these functions to allow them to function as intended, pun intended. You configure your project beforehand, and you can always change these configurations later if you need to. Now, step number 2 would be to write your code. This can be the backend code that works as your business logic for your application or website. It can be a microservice, a deep learning algorithm, a meme generator, or any other computational task really. It can take incoming data and decide what to do with it. In our case, it's going to take incoming data and look at the database and decide whether to persist this data, validate it, and then send a response that is either successful or failed. Now, step number 3 would be to upload your code. Now, I understand you can write your code on the Lambda console, but I personally prefer to write it on my machine and then upload it to the cloud. You can also write the code on the console, but I think there are some benefits to writing it on your machine, which we'll get into later. Now, the last thing is to let Lambda do the magic, which means essentially is you let it wait for any request or any trigger to these functions, and what it will do is it will start a wrapper whenever any of these functions are requested, and this wrapper will run for I think 2 minutes, and then take your incoming calls, and then whenever it doesn't need to run anymore, it goes off, which means it's not running a server all the time, which is why it's super cost efficient in a lot of scenarios. And what you get with the free tier is actually 1 million free requests per month. And once you exceed that, you only pay $20 per 1 million requests from that point on, which is super cheap. Now, this is an example of a simple Lambda function. So this is our function, which is called hello world, and it takes in 3 things: the event, which holds the incoming data. So in our case, it's going to have the body of the request and the headers, and we are mainly concerned with the body. And we have the context, which holds some environment variables and other metadata. And we have the callback, which we're going to use to send back a response of either if we have an error, we can send it. We can set the first argument of this function as an error, which will log an error to the AWS console. And the second argument will have the response. And if we don't have any error, we will set the first error argument as null and set the response, which could hold a status code and some data. So in this case, we just say hello world. Now, what is DynamoDB? Briefly, DynamoDB is a NoSQL document-based database, kind of like MongoDB, but with a different syntax. Now, DynamoDB has a lot of optimizations that are being done under the hood that makes it super fast and super scalable, and it's fully managed. That means you don't need to manage anything that relates to locations of the database, because it actually has it spreads automatically to 3 geographically different data centers for more availability. The data that you have on DynamoDB is actually stored on SSDs, solid state drives, instead of traditional hard drives, which makes it way more performant. It's got really high, low latency, and it manages loads automatically. So if you have more requests, more load, it scales up automatically for you, and it's fully customizable. You can set anything you want. You can set the read capacity, which we'll see later, of depending on how much traffic you're expecting. Enough of the theory, and let's actually jump into the code. Our API is going to have one main resource, which is going to be posts. And it's going to be similar to, actually identical to the post resource from the JSON placeholder API. So if I scroll down here, just to show you as an example, our posts are going to be like this. They're going to have a user ID, which is going to be hard-coded because we don't actually have users right now, an ID, auto-generated by our code, a title and a body, which are received when a user sends a post request to our API. So let's start actually implementing our project. So here on my desktop, I'm going to open a terminal window. For us to create a project, we need to actually first install the serverless framework. So let's say serverless npm install serverless-g. I already have it installed. So once you install it, let's make a directory. So let's call this SLS API. Let's cd into it. And we can use serverless, or we can say SLS for short. And here we need to say SLS create, and we need to give a template because it can be any language. So -t, and we'll say AWS Node.js and hit enter, and this will now create our project. Alright, I'm going to run code dot to open it in VS Code. And we get these two files, the handler, which is where our functions are going to sit, and the serverless YAML file, which is the configuration file. I'm going to remove all the comments because there's too many of them and they overwhelm me. And here, let's remove all of this as well. It's giving you examples, but I'm not going to use them. So here, I'm going to leave these two, the name AWS and the runtime node. I'm fine with that. I'm going to add a custom environment object. So I'm going to say environment, make sure you spell things correctly because there's no IntelliSense here. And here I'll say, actually I need to create a custom entry here. Let's say custom, and here I'll call this settings, and let's have a key called post table, and this will refer to our post table, and I'm gonna call this just posts. This is gonna be our DynamoDB table. And here, actually, I forgot to mention that this service, this is important, this name, this is going to be a prefix to your functions. So if I call this SLS, which I will, any function that will have an SLS dash the name of the stage, which initially is going to be dev dash the name of the function that we create. So if we have a create post function, it's going to be SLS dash dev dash create post. Alright, so here for our environment, we need to say $ curly brace to refer to our custom entry, say self for this file, colon, custom dot settings. Now we have access to these variables. And here actually I need to set an IAM role to give permissions to my functions to operate some things. And I'll show you what these things are. So IAM role statements, and here hit enter, space dash space effect, and this will have the value of a string called allow, and here we'll have action. By the way, these are Pascal cased, so make sure you have capitals at the start, space dash, and here we'll have a list of the actions that we want to allow this role to give to our functions. And these will be, so we'll start with DynamoDB, all in lowercase, colon, describe table. And I'm gonna copy this. Describe table gives it the ability to actually know metadata about the table. I'm gonna actually paste this a couple more times. So this will be a scan, which returns a couple of items, multiple items. This will be get item, which gets one item. This will be put item, which creates one item. So we update item, which does that. And this will be delete item, which does exactly that. And here we'll say have an entry resource, and here we'll give which resource this role applies to. And here let's do a string, say ARN for Amazon resource name, AWS, so colon AWS colon DynamoDB colon, and here we give the want to give the region. Oh, actually I need to set my region. Maybe you don't need to set your region because the default region is US East 1, North Virginia. For me, my nearest region will be London, which is EU West 2. And you need to do a bit of research. I mean, you just Google which region is closest to you in AWS and use that. So here I'll refer to that. So $ curly brace self colon provider dot region. And close the braces and do colon star colon, and here we need to actually give the table. So I say table slash, and we need to give the name of the table. So $ curly brace self colon custom dot settings dot so posts table that we created earlier, and close the curly brace. Alright, so here we actually already have a function hello. I'm gonna change this, call this create, oops, actually lowercase. Here I'll say create post. Here we need to give it some events so it knows what triggers this function. Here I'll say dash space, and it's gonna be triggered by a HTTP request. And here we need to specify, oops, actually a path for this HTTP request. It's gonna be from actually slash post, and a method, which is going to be a post method, because this is the method we use to create post. We'll add more later, but for now let's actually add the resources key. So let's say resources like this, and this will have another key, resources, with a capital R, and inside of here we'll have, let's call this posts table. And here we'll have a type of this resource, which is going to be AWS colon colon DynamoDB colon colon table. And here we'll have some properties. And here the first property, we need to specify some attributes. Let's say attribute definitions. And all of this is in documentation, obviously. I'm not making this up off the top of my head. So attribute name. And here we need to specify the primary key, or the partition key rather. So this will be the ID, and I'm gonna give it another key called attribute type, and the type of this will be a string, so S like this. And here we need to say key schema, and here I'll say actually like this, dash space attribute name. This is going to be the ID, and we need to tell this that this key, so key type, and we need to say all caps hash, which will tell it that this is the partition key. And if you want to know more about the partition key, I'll post by the way, I'll post links in the description for the documentation, so you can read more about DynamoDB and all the stuff that we're using. Here we'll specify provisioned throughput. Yeah, provisioned throughput, that's it. So here we need to specify two things: read capacity, and I'll explain in a second. Read capacity, actually units, I'm gonna say 1, and write capacity units of 1 as well. What this means is that when we give read capacity of 1, this means that we're giving it the capacity to perform 3,600 reads per hour. So if we give 2, it's going to be double that, and if we give 10, it's going to be 36,000. And if we surpass this amount of traffic, then AWS will let us know by email that we've surpassed this and we need to change this setting so we can scale up our service. And we will only be charged once 10 units are consumed. And of course we get a couple of free units because of the free tier benefits. So here we need to specify the table name. So table name, and this is going to be in our settings. So here we do curly braces self colon custom dot settings dot posts table. So now let's actually create our create post function. Here first we need to get a reference to the AWS SDK. So let's say const AWS equals require AWS -SDK, and we need a reference for the DynamoDB, and I'm going to call it DB. So const DB equals I'm going to instantiate a new instance of it, DynamoDB document client. And here we can specify some options. I don't think we need to specify the version, but I'm going to do it. So API version, I'm just going to be explicit about it. And there's two versions for the DynamoDB. There's this one and the latest one. I'm going to use the latest one. So I'm just going to copy this and go back here and paste it. Oops, go back here. All right. And we need to get a reference for our post table from the environment variable. So I'll say const post table equals process dot environment dot posts table, like this. All right, so here actually we don't need this hello function. We can delete it. We can say module dot exports dot create post equals, it's going to take an event, the context, and the callback that we'll call later. So to recap, the event holds information like headers, like the body of the request and other metadata. The context holds some context of like environment variables and some AWS stuff. And the callback is what you will use later to send a response or an error to the AWS console. So here we actually need to parse the incoming data. So let's say const rec body for request body equals, let's say json.parse, and here we pass the event.body, which is the request body. And here we'll form our post object. So here we say const post equals an object with the ID of, actually here we need to use UUID. So here in the console I'm going to do npm init -y to quickly initialize an npm project and say npm install UUID to get UUID. Now that it's installed, we can actually get an instance of it. Let's say const or import it, UUID equals require UUID/v4 to generate a random universally uniform ID. Here we call it as a function. Oops, no semicolon. And here we say created at, we need a created at, and it's just going to be a new date. And I'm going to change the to ISO string method to make it an ISO string. And here we'll have a user ID, which is just hard coded to be 1. And here we'll have the title, which we'll get from the request body. So request body.title, and the body from request body as well, .body. Now here we need to use DynamoDB to persist our data. So we need to actually return this. So let's say return db dot, we use put to create one item, and we need some parameters. And here we just need two parameters: the table name, Pascal cased, by the way, so capital T, table name, which is going to be posts, post table reference, and we need the item, Pascal cased again, which is going to be the post item. And the way this works is you give some parameters and a callback, but I don't like this syntax for callback, because if you need to do more stuff, you need another callback and you're going to end up in callback hell. So instead, I'm going to chain the promise method to make it a promise, and then chain then. And here I'm not going to use anything from the response, and I'm going to say, so if we get here, that means we've been successful in our persistence. So we say call back, and the first argument is going to be null because we have no error. And here, actually, I'm going to create a helper function to create a response, because I'll show you why in a second. Here we'll say const, or actually I could just use the function keyword. So function response, and we're going to give it two things, a status code and a message, which can be an object. So here we'll say we just return an object with the status code of status code, and here the we need a body of JSON.stringify message, because it can be an object, and that's it. And here, so null for the error, and we need to generate a response and use our function, and our status code is going to be 201 for created, and our message will actually we'll just return that post that we created. And here let's chain a dot catch in case we get any error. And here we'll actually do so response, and here actually instead of passing error as the first argument, the problem with this approach is that it raises an error to our AWS console, and to the client then send the API request, they will get a 502 error for server error, when actually it could be a client error. So instead I'm gonna say null, which for a second gives the illusion that there is no error, but I will give a error code in the response. So I'll say response, and this I will give it the error status code, so the status code of our error that we got, because it holds that, and for the message is going to be the error itself. Alright, so let's save this, and we're done with our first function, so we can run SLS deploy. Alright, it says path property in function create post is missing or invalid. I think it's because of the indentation. I'm going to indent this one more space or one more tab and do SLS deploy again. Alright, so our create post function has been deployed. So let's copy this endpoint. Let's test it. Let's go to Postman. Let's paste this endpoint. Change the post to change the method to post, and go to body raw and select application JSON. And here we'll send an object with the property title. Let's say post1, and a body. Let's say this is the first post. Let's send the request, and we get internal server error. And this could happen sometimes because sometimes it takes a brief period of time to create the role and propagate everything properly on the AWS console. So I'll give it maybe like 2 minutes and then test again. Alright, so let's try again. And there we go, it works. Our post is created and we get our post back. Alright, so let's go to our console and see what's happening. Alright, so I'm gonna go to DynamoDB first. And here we go to tables, and there we go, we see our post table has been created. And if we go to items, we see that our item that we sent has been persisted. Alright, so the other thing as well, we can go to Lambda, and we can see that our function has been created, sls-dev-create post, and we can see our code here, and we can interact with it. We can actually edit it here and save here, and yeah. Alright, so let's go back to our code and write the rest of our functions. So here in the serverless YAML, I'm just gonna copy this. I'm gonna paste it. Here, select this and Control D. I'm gonna create the get all posts function to get all posts, and the path will be to /posts, and the method will be a get. I'm gonna copy this. Oops, actually, let's go back here to be indented properly, and this will be called get posts. And this is different, that it gets a specific number of posts, and this will be to /posts / curly brace number as a parameter, URL parameter. And here we'll paste it one more time, and this will be get post. Again, get post, and this will be to /post ID, and this will be a get request as well to get one post. Let's paste it one more time, and here we have the update post to do just that, and it will be to /post/ID, and it will be a put request. And one more time, this will be delete post, and this will be to /post/curly braces ID, and this will be a delete method, a delete request. Alright, let's save and let's go to our handler. Let me close the terminal. Let's create the rest of the functions. Actually, I'm going to put some comments. So here, create a response. Here we'll say create a post. And here we'll say get all posts. This will be module.exports.get all posts. We'll take the event, the context, the callback. Now we don't need the event and the context in this one, but we need to write both of them so that we can access the callback. So for get all posts, we need to do return db.scan, and we need to pass the parameters, actually only one parameter, which is the table name, Pascal cased again, and it will be posts table. Again, we will do .promise .then, and we get a result, and here we'll say callback null, and the data that we return res.items, which hold the items that we got, but actually I want to sort them, so we'll do the JavaScript sort method. Here we'll say A, B. Well, actually I'm going to use this sort a couple of times, so let's create it in its own function. I'm going to call it sort by date. I'm going to create it here. Let's say const or function sort by date takes A and B, and if A dot created at is bigger than B dot created at, then we return -1, else we return 1. Alright, so we just pass to the sort by date, and it will actually sort our data. And we need to chain here .catch in case we get an error. We say call back with null. Well, actually this is, we need to do use our response. So we say response 200 for success, and we pass our data in the second parameter of the response. And here we call back null, and we say response, and the error code will be error.status code, and the data will be the error itself. Alright, so let's create the get number of posts. So this will be module.exports.get posts, and this will have an event. It will take the event, context, and callback, same as the other ones. And here we need to get the number of posts from the URL. So let's say const number of posts equals, it's going to be in the event dot path parameters dot number. Actually, let me make sure I call that, yeah, call that number. All right, now we have the number. I've seen this in the documentations that they have a parameters object and then they just pass it to make it more readable. So I'll do that here. So table name will be post table, and we have a key called limit, and it's going to be the number of posts that we got from the URL. And here we need to say return db.scan params. So now because of the limit, it's going to return just that number of posts. So here we say .promise, and we chain .then, and we get a result. We'll pretty much do the same thing as here. So let's just copy it from this .then to the end, and we just paste it here. It's the same process. Here, let's I'm going to copy this. Say get a single post and paste it and remove all of this, and this will be just get post, and here we need to get the ID from the URL. So the URL parameter, so equals event.path parameters.id, and here we'll say return db.get, and or actually let's put these parameters like we did earlier. So const params equals an object, and we have a key, and this key will be the ID of one's gonna have the value of ID. So this is how we filter for results. And of course the table name will be post table, and here we'll say get params dot promise dot then, and then we get a result. And here we need to check if we have a post, because we could not have it. So let's say if res.item, so if we have it, it's going to be put in the item. So if we have it, if this is not null, so just call back null, and here we'll say response 200, and the data will be res.item. So here we'll say else call back null, and response the error will be 404, and we'll pass an object saying error post or post not found. Alright, and here we'll say catch in case an error happens. So actually the same thing, I'm just gonna copy this, paste it here, and we're done with get post. Actually, before we carry on, one thing I was meant to do is here in the create post, we could have like empty fields or fields that don't exist in the title and body, in the body. So what we need to do, I'm just going to do some very crude validation and say if request body, or actually I'll say if not request body dot title or request body dot title equals, or dot trim as well, we need to chain because we could have some white spaces, equals an empty string, or, so I'm just gonna copy this one more time and then select this, Control D, body. So if we don't have a title property, or we have it but it's empty, or we don't have a property of body, or we have it and it's empty, if any of these is true, then we have a validation error, and we just say return callback null, and here we'll say response, and we'll give an error of 400 bad request, and we'll say error, and let's say post must have a title and a body, and they must not be empty. Alright, you can of course customize that and make the validation more specific, but I'm just gonna leave it like that for now. Alright, here I'll say update a post, here we'll say module.exports, not comma, dot exports dot update post. We'll take an event, a context, callback, and here we need to get the ID. So let's say const ID equals event dot path parameters dot ID, and here we'll say const body equals JSON dot parse event dot body, just like we did in the create post function. And the way DynamoDB works is that you can only update one field at a time. So when you're working with the front end, you actually need to structure your front end around this functionality. So here I'll show you in a second how this works, but bear with me for a second. Let's say param name equals body, which is the request body, dot param name, and let's say const param value is body dot param value. We could actually destructure it, but I'm not sure if it's working in node 10. I'm just gonna leave it node 8. I'm just gonna leave it like this. So const params equals, here we'll pass a key, which is gonna be the ID, which is gonna be the same as the ID that we passed. So we need to get to this document from this table. So table name post table, and here we need to say condition expression, and the expression will be attribute underscore exists ID. Needs to have an ID, and here we need to say update expression, and the expression will be, so set space plus, so you concatenate param name and then plus, and then string space equals space colon v, which is going to be the value. So we set the param name, whatever the param name is. For example, if we want to edit the body, we'll say it will be set body and then the value, and this value will be, so we'll say expression attribute values equals an object, and here we'll say colon v, the one we used earlier, equals param value, and here we'll say return return value all new. And this will allow us to actually have a free read after we edit our item, so that we can return it to the client or to whoever requested this. So here we'll say db return db dot update, and we pass it our params dot promise dot then, and we get a result, and here we'll say callback null response, and the code will be 200, and we'll say the data will be res dot attributes, and here I'll say, or actually I'll just send the res, just to send the result itself. Here we'll have a dot catch in case, so error, we call back null, and the response of error dot status code, and the data will be the error itself. So yeah, we're done with updating. Here let's say, so bear with me guys, we'll write all the functions and then test them all together. So delete a post, here let's say module dot exports dot delete, delete, I always struggle to spell delete for some reason. So here event context and callback. Here we need to get the ID from the URL, so const ID equals event.path parameters.id, and here we have our params. See, it's getting repetitive because they're kind of similar, because this is how CRUD works anyways. You write some code and then you get the vibe and then you write some similar code to it. Alright, so get the key, which is the ID, and the table name, so table name, which is our post table, and here we just return db.delete, pass it the params, params, and here we say .promise, then have no result, we just, actually I could just do it in one line, callback null, and response 200, and we'll just pass an object with a message of post deleted, oh god, successfully. And here, oops again, what is happening? Dot catch error we call back null and a response of the error.status code, and the data will be the error itself. And we are done, I think. Alright, let's save. Let's open the console and do SLS deploy, and let's cross our fingers and hope everything works. Alright, so now that everything has been deployed, let's copy one of the endpoints. So let's go here. I'm gonna open a new tab. So here I'm gonna add an S at the end and leave it as a GET request. This should be the get all posts. Alright, we get internal server error. Again, maybe it's the permission thing. I'll just give it some time. Alright, let's try again. Still not working. Alright, let's go to our Lambda console. So let's go to get all posts. Let's actually test it here. I'm just gonna give it like EE here. Create, test. It fails. Alright, so invalid shorthand property initializer, syntax error. Let's look at the code here. Oh, okay, my bad. I put an equal inside of an object, which is obviously wrong. So what I can do, it can go here. Where is it? Yeah, the update one here. Just it's colon instead of equal. My bad. You probably didn't have this error. I'm gonna run SLS deploy and try again. Alright, now let's try again. Alright, so the posts gets us all the posts that we have, which are only one. So let's actually try to post a post. So change that to post and remove the S and select application JSON. Or actually we already have that formatted here. Here let's type post2 and say second, and let's hit send. Our post must have a title and a body, and they must not be empty. So I messed up something in the validation. Oh, my bad. Here is we need to compare this to an empty string as well. I'm gonna again run SLS deploy. Alright, let's go try again. Third time is the charm, I guess. Let's send this. Cool, so the second post has been created, and if we, let's go here, and if we send a get request, a get request to /posts, so remove the body, it's gonna get us our posts, and they are sorted by descending order of created at. Alright, let's create one more, just for the sake of it. And here's a third, create, it creates it. And let's actually try the one that limits. So here if we do like this, it gets us all our posts. So if we do / a number of posts, so if we do 2, we should get only 2 posts now. Cool, and we do. If we get 1, we get only 1. And if you put a number that's much bigger, it's okay, it's just gonna get all of them. Alright, so let's actually try to get 1 post. So let's take an ID, so of post 2 from here, and we do to /post / the ID, and we send. And we get only that post. All what else? Let's try to edit a post. So here we send a put request to the same endpoint, to /post / ID, and here we need to send param name, and let's edit the title. So the param name would be the title, and param value will be, let's change it from post to the title to the second post, like this. Let's hit send, and we get an empty object. Interesting. Okay, so let's try to get the same post again. Alright, it's been edited, but we get an empty object. So actually I need to return that post. But it's working, so you can actually edit that yourself. Let's try the delete. So let me delete the second post. So change this to delete. Without a body, we send, and we get post deleted successfully. And if we try to get the posts again, so get /posts, we get 1 and 3, and 2 has been deleted. Cool, so our API is fully functional now. We have full CRUD functionality, and yeah, we're done with this video. And by the way, guys, there's so much more to DynamoDB. You have to, if you actually want to deploy it in production, you need to read a bit more about it. It's focused more on reads than writes. 5 reads cost the same as 1 write, so you need to make sure that your application suits DynamoDB and Lambda for you to use these 2 services. Anyway, this is it for this video. I hope you enjoyed and learned from it. Sorry for the errors at the end. I actually had to re-record this video 2 times over because of some mistakes. Like this video if you liked it. If you're new to this channel, feel free to hit the subscribe and the bell buttons so you'll be up to date with my latest videos. And let me know in the comments whether you like AWS content and if you like me to cover any other topic. Thank you for watching, and I hope to see you soon. Bye.